Okay, and then we get into starting the engine and spinning the rotor. So it tells us that we have the option of doing a battery start or starting with external power. And I'm just going to do the battery start, and it gives us the lights we can expect, which do match up to the lights that we have on right now. And then it gives us an idea of how the lights are going to extinguish and in what order during the startup. Okay, so we'll get into the startup here. And first step is set the boost pump switch to on position. And let me see, it tells us that we should be able to hear it and that we would check the ammeter to see an increase in the electrical load. And we have a voltmeter right here. I have not been able to find an ammeter for measuring the amperage off the system in the cockpit. It could be here, but I don't think that in this model we're going to have amperage displayed, only voltage. So in either case, I'm not really that worried about it. So let's go ahead and go to fuel pump on. And when I do that, I'm going to start the timer right here because I'm looking for 20 seconds. And then it tells me after 20 seconds, I position this switch to start and then run. And this is different from, definitely different from the type we have here, because all I'm going to do is put it up to the M on position. I don't think this is, in this model, what it is in the model that I have documentation on. So let's go ahead and do that. Let's go ahead and go up to the M setting. So I have the green light on and the yellow light on. The yellow light is going to be telling me that the igniter is functioning and that fuel is being sort of augmented into the igniter, and that's going to get the engine up and running. I can see the RPMs starting to come up, and let's see here. The green light goes out. That tells me that the generator kicks in, I believe. And then I should get the yellow light out telling me that the igniter system has cut off. Let me double check that. That's the complete primary start right there. Let me double check that. Something just doesn't feel right here. I'll be right back. Okay, I'm back. I restarted the mission and I'm right back at the same spot we just left off. So the green light right here, DEM, is start. That comes on when, just when the start cycle commences. The yellow light is telling me that the electronic fuel cock has opened, and that is providing additional fuel to the injector. And yeah, I mean, according to everything that I have, that was supposed to go off as part of the start cycle, but I think maybe that'll go off once I get a little bit further in. I think it comes down to the difference between the function of this switch, and I'll go ahead and go on, and in the model that we have here and the models that I have the real documentation for, so you can see the temperature coming up and stabilizing. And then I'm going to get the RPM starts to come up, and that's going to keep going past 14,000 all the way up to ground idle, which is a little over 20,000 RPM. And yeah, there we go. The start light goes off, telling me that the start cycle has completed. Actually, I have the generator on, and you can see that the voltage went to 28, so this is voltage coming off the generator. And the yellow light is still on, but I think maybe that's going to go off later as part of the sequence for this type of aircraft. So, okay, I'll take that as is. So, okay, when engine RPM tends to stabilize at 14,000 RPM, and I'm looking at a hypothetical failure that we could run into here. If it stabilizes at 14,000 RPM, it's a stagnation phenomenon. Move the selector switch back to the off position without stopping the boost pump, and then switch the pump off 10 seconds later. So I don't think we'll run into that, but we do have a procedure right here to deal with that. Okay, so pressing on to, set controls to neutral and disconnect the ground power unit if connected, and that's not applicable since we did the battery start. And then gradually move the fuel flow control lever forward up to the engine speed at which the rotor begins to rotate, and then start the clock. So let me go ahead and reset this back to chronometer reset, and I'll be able to start this again. And then I'm going to time the time it takes from this point the rotor starts to the point that the RPM gauge for the rotor and the turbine synchronize. So right now the turbine is running at ground idle at about 25,000 RPM. Once I start to move the little throttle lever, or I guess it calls it the fuel flow control lever, forward, then both the turbine and the rotor RPM are going to start going up. The rotor RPM is going to start to increase once a slip clutch, or I guess that's, to use a better term, it's actually, I forget the exact term. It's not a slip clutch, but it's a clutch that has a sort of a drum and then shoes. So once it's a centrifugal clutch. So once the RPMs build up to the point where centrifugal force expands and just makes the boots go outward, then it engages on the main rotor, and that's what starts to turn the rotor. And like I said, I have the rotor brake engaged right now, but since I'm about to spin the rotor, I'll go ahead and disengage the rotor brake, and it's just going to be a matter of getting it up to the right RPM for that clutch to engage and for the rotor to start spinning. Now, additional things I'm going to be looking for here. Let me read ahead real quick because I know there's one or two things I'm missing, and I'll be right back. Okay, so I have some minimum RPMs right here listed for when the clutch is supposed to engage. I'm at about 25,000 RPM right now, so anywhere from 27 to 33,000, and then depending on where it is in that range, it's going to tell me different things about the condition of the clutch itself. It's also telling me here that I'm supposed to increase the fuel flow control, and then it's all just going to stabilize right there at that little tick mark that my cursor is next to right now. So what I'm going to do is just click and hold, and then slowly increase. So we should be up through, about 27,000. There we go. The clutch just kicked in. We've got the RPM coming up, and I'm supposed to actually start the clock there. Now I just need to measure 30 to 45 seconds, and I can increase the throttle there. I'm a little bit late on the time schedule here. So there we go. That's going to be all the way up, and that is locked in the forward position right now. And it's coming up about 20 seconds in, and that's about halfway there. RPM for the turbine has stabilized. I've got, still good temperatures. And the lights, I didn't really pay attention to them, but the lights did go off, I'm sure, in the correct sequence right there, with the oil pressures kicking in, and then the RPMs reaching their minimum threshold for the, I've got synchronization right there, and that was probably at about 35 seconds or so. Okay, so, that was perfect. That was exactly what I was looking for. And I think, next time I'll just sort of work the lights into my little sweep around the cockpit here. But that's the start. So let's see what the procedure here tells us to do next. So, okay, this is all done, all the way down to... Okay, then we get into checks after engine start. So external power source disconnected, that is done. Engine oil pressure and temperature are correct. So engine oil temperature is right down here. That's stabilized at about 60, and that's... Is that turbine or is that rotor? Okay, this one is turbine, and this one, T4. This one, well, I'm confused now. Let me see which is which when it comes to temperatures. I'll be right back. Okay, so I'm back. So the top temperature is turbine oil temperature. That's the way that I interpret everything that I've read so far. I was expecting a temperature maybe for like the main rotor gearbox, but this is turbine. And then the bottom one, T4, is sort of like the fourth stage turbine temperature, sort of like what we would associate with, I guess, just like ITT, our turbine temperature in the A10. Same thing. So turbine temperature and then oil temperature, both for the turbine. Okay, got that. So then we get into, then pilot heating if fitted on. And that's not pitot, but that would be just ECS controls. And I looked around just a couple minutes ago for some like cockpit heating or ECS type things, and it's probably here. I just probably can't figure out where it is, but I'll take that as good. Okay, voltage on voltmeter correct, and coming off of the generator I should be at about 20. I was expecting 28.5 actually from some documentation, but it's right in there around 28, so that's just fine. Servo test unit off, check loads, reset to on. And I just looked for that, and I can't find anything that's a servo unit test. So I'll take that as good. I'll re-engage on that if I do find something that stands out. All warning lights off, except for the ones that are expected. So pitot and PA for the autopilot are the ones that should be on at this point. So that's good. And then navigation, and radio communication, checking for correct operation. So this is my first opportunity to get into the radios. So let me take a few minutes here just to look around so I'm not stumbling through this part of it, and I'll be right back. Okay, and I'm starting with the VHF radio. This is what I was going to use just to do a quick comms check with the tower. Now, let me switch over to the other seat. There was something here I was missing. You can see the M and the A for on and off. If I think I've got it right there. Yeah, there we go. You can't really see where it's pointing to, but there's an on and off switch, and then there's a rotary dial. So for like the tooltip, yeah, that's the on off switch. That's the rotary dial. So you just have to now switch over to the other seat. And same view from over here. Yeah, just on and off, and then rotary dials to change the whole number and then the decimal number over here. So I was going for 122. Yeah, 122 is correct. So let's go for ATC Creech request startup and see if we get a response. Okay, so far so good. So that's VHF. That's up and running. Now I have my flight on. What do I have my flight on? I'll be right back. Okay, so I have my flight on 124, and it's handy to have these recordings of the mission planning right here that I can reference. Well, I say handy, that's the first time I've ever done that. So let's go over to 124 and 123, 124. Let's go for back out of that. Let's go for flight. I wish, like in the F-15, there's a check-in feature for radio communications controls. I just really wish that this was standardized aircraft to aircraft, but I know I'm just going to go in circles trying to do this on the ground. I always do, so I'm just going to ignore that. We just really need for all aircraft to have that check-in radio function. I want to use it all the time, but I just never can. Okay, so that's VHF. Now, let me see if I can do anything with the FM radio. So I'll be right back. Okay, so FM radio, 2 dials here. I have this dial. It's in the AR or off position. Either of the 3 additional settings, I believe, are going to function the same. And then test just gives me a tone just for operational testing usage. Now, that is really all that we get here in the manual. Now, what I wanted to try to do was to go to 38.6 and contact the tower on FM. So let me just, for the heck of it, turn the VHF radio off. Okay, there we go. VHF radio off, so now the only one I have up is FM. I'm on one of the 3 settings that should give me functionality. Now, what I want to do is set this to 38.6. So let's go and type in 38. Okay, let me see if I can figure this out. I'll be right back. Okay, I'm back. I feel as if there's going to be a way to manually input values here, but at the very least, the bottom dial allows me to switch between the presets that we saw in the mission editor, but yeah, unfortunately, these are just all whole numbers, so I couldn't really do a decimal in the mission editor, but hey, no big deal. I don't see myself using this for much other than just contacting JTACs or whatever during missions, and all that stuff will be set to a whole number frequency, I'm sure, by a mission designer. Now, additionally, I have a UHF radio, and this one's going to be a little difficult, I believe. So let me get to a better vantage point to see this one. I'll be right back. Okay, so for this one, I'm over in the left-hand seat. I was kind of blocked by my collective earlier, so it's in the off position right now. And then any of the positions, really, according to the manual, are going to work the same. So I just put it into any position here, and then to change the frequency, I simply type it in. I'll go for 251. So 251 000, and then hit VOD, and that's how you would set that. Now, let me do a radio check with the tower on UHF. So let's go for ATC Creech. Let's say I'll just go ahead and do a request hover check. I think that's up next anyway. Okay, I'm back. I could get no response from the tower on 251. That's the Creech frequency that I have through the mission editor and through other sources. So you never really can tell with ATC whether it's something you're doing wrong with the aircraft or it's just something up with the work in progress nature of DCS2. So okay, I'll take that as a good enough radio check for now. And for now, let me go ahead and turn off the UHF radio. I'll go back on VHF and go back to 122. And let me try it this way. Let me go ahead and call for a hover check if 2. Yeah, okay. I don't know. Maybe I just had something misconfigured there on the UHF, but okay. I'll take that as good. Good enough at least. I know that at least on VHF I can communicate, so that's all that I really need. Okay, so let's get into checks before takeoff. Collective pitch stop adjusted. Now we get into some more cool stuff about the aircraft itself. Now, there's going to be a stop that you're going to have sort of pre-adjusted. That is, you can see the little tick marks right here, 7 degrees, 8.8 degrees, 9.9 degrees, and that is referring to the pitch of the blades. And I believe the stop would be adjusted to 4.4. Let me go to the manual real quick. I'll be right back. And this is, I guess, really beyond the scope of what is reasonable to model in a simulation like this, but you can read this section right here if you want to pause. But it would be adjusted to a nominal 4-degree pitch, and then there would be additional detents that would be adjusted based on several factors, and then there would be like a friction control that we can see actually modeled in 3D right there. But yeah, it's really not going to matter for us. I'm just going to skip that part. Interesting read though, but yeah, it's not going to be anything that really does anything for us. Okay, torque meter index set. So we already have that set at 93 based on the chart that we referenced earlier. Okay, fuel flow control lever, verify forward stop, and it is all the way locked at the forward stop. Okay, warning lights all out. Engine oil temperature and pressure correct, voltmeter and ammeter correct. SAS, if fitted, engaged. Yaw, roll, and pitch mode switched on. And then I have a check that I run. So let's go ahead and get that. And I do have the autopilot and the pitot lights on there. I'll go ahead and get the pitot to extinguish that light. And then for the SAS, I'm going to come down here. I'm going to go to the main switch. It's labeled autopilot on off. Turn that on, and that's going to extinguish the last of the lights. I'm going to engage the roll, pitch, and yaw channels, and then I'm going to leave this switch in the center off position for the altitude and speed hold mode. So right now the SAS is, as far as I can tell, engaged. Now we're going to do a check, and the check is at 214.1. So let's go ahead and skip on back to the back here. Okay, and for an operational check, it's telling me to depress the SAS disengage button on my cyclic, and I have what I assume is that same function. It's the autopilot master button as you're looking at it in your control menu. I'm going to depress that, and what it's telling me is that the main switch should trip. It's magnetically held in place, and if I disengage it, the switch trips. And what I'm finding here is I've actually run through it a couple of times already, is that it does disengage. We go off scale low on our sort of needles for just where the SAS is pointed right there, so it does trip off, but the main switch doesn't trip. If I depress it again, it's acting as an on-off toggle and not just like strictly a disengage button. That's not to say that it's modeled wrong. I would actually say that anything that's different here from the manual that I'm operating right now and how it operates in sim, the sim is probably right for this variant. But yeah, that does function, and that's a good operational check. I depressed it again, it is off. Depressed it one more time, and then it kicks back on. So I'm happy with that as an operational check of the SAS. And I have another check, checking the magnetic brakes. Momentarily depress the magnetic brake push button on the cyclic, and the stick should be free. Release the button, and the stick should be anchored again, and carry out the same check for the co-pilot lever. So the way this would work is I would depress the button for the magnetic brake, and as long as I have it held in, the stick should be free. I'll center it back up, release, and then if I had a force feedback switch, or, well, if I were in the real world, the magnetic brake would sort of hold it centered at wherever I release the button. So this one is sort of like a depress, move, and then release for it to kick in type stick. Which, yeah, for my purposes, it's not functional on a non-force feedback stick to begin with, so it doesn't really matter, and I don't think I'm ever going to actually use that, in fact. So, let me see, checking the torque meter, we have another check here. So, press the test button, the pointer should stop opposite the 0 mark, and the maximum torque warning light should flash. Okay, so let's try that. We have a button up here on the torque meter. Depress it. Okay, so yeah, there we go. The light's on. Yeah, on, flash. I'll take that. That works. Okay, let's see what else we have. So we have checking the condition of the engine, and this check is carried out during flight. So I'll get to that once we're airborne. And I'm debating whether I want to get airborne right now or do the shutdown, since I've actually been at this a lot longer than I've shown here. And yeah, either way, I'm going to shut down and take a break here. Yeah, I think I will come back in the next segment with getting the aircraft airborne, hover taxi, and yeah, coming back fresh, I'll probably actually do some navigation as well. So I will be back in a little bit.